the birth of the body where heat meets shape. Before light can exist, it needs a home. That home, the LED bulb body. It's built to be strong, heat-resistant, and light-friendly. The process begins with placing the aluminum heat sink. That's not just any piece of metal. This is a vital part of the bulb that pulls away heat, keeping things cool even when the light's been on for hours. If it weren't there, the LED chip would burn out faster than you could say eco-friendly. After the heat sink is set, the base of the bulb starts taking shape through injection molding. Picture this: molten plastic. Hot and gooey, being injected into perfectly shaped molds. In seconds, it cools and hardens into the shell that will eventually hold all the inner components. It's fast, precise, and oddly satisfying to watch. Now it's starting to look like something real. Not just a blob of plastic and aluminum, but the beginning of something that will one day light up a room. The LED chip? Tiny but mighty. At the heart of every LED bulb is a tiny yellow square, the LED chip. Don't let its size fool you. This is the real light maker. It's like the engine in a car or the CPU in a computer. Small but essential. The process kicks off with surface mount technology, or SMT, where these chips are delicately placed onto circuit boards with almost inhuman precision. Machines do this part because the chips are tiny, like really tiny. Trying to place them manually would be like threading a needle while blindfolded with chopsticks. But for all the machine magic, there's still a human touch involved. Skilled workers step into solder wires onto the direct-on-board DOB LEDPCBS. It's a careful process. Each connection matters. A single weak joint and the bulb might never shine. And then come the IC drivers, little integrated circuits that control how power flows through the bulb. These are separated, sorted, and soldered onto the LEDPCBS, again by hand. Not because machines can't do it, but because these drivers are delicate, and sometimes machines just don't have the finesse. Some LED bulbs are compact, with IC drivers so tightly packed that assembling them by hand is the only option. Add to that certain sockets like the B22, which require hand assembly because automated tools just can't handle the design. It's a blend of automation and craftsmanship that keeps the process flowing. The driver, invisible but essential. Ever wonder how a bulb handles the electricity straight from your wall outlet? That's where the driver comes in. It's the silent workhorse hidden in the base, making sure everything runs smoothly from the moment power hits the socket. Tucked away inside the bulb's foundation is a small but essential circuit board that acts like a translator in taking the high voltage alternating current, AC, that flows through household wiring and converting it into the low voltage, steady direct current, DC, that the LED chip requires to shine bright without burning out. Without this component, flipping the switch wouldn't do anything but send raw voltage to a chip that's just not built for it. The journey of the driver begins with delicate precision. First, there's the soldering. Wires must be connected to just the right points, with clean joints that won't fail or under long hours of use. It's not simply about connecting parts, it's about ensuring those connections can handle surges, dips, and constant current flow. The driver board itself is mounted with care, often by hand, especially in more compact bulb designs where machines can't easily reach. These tight configurations demand human finesse, and the workers handling this part are incredibly skilled at making sure every lead is placed perfectly. Some LED bulbs operate with external or modular IC drivers, which are small integrated chips that regulate power flow. Others go the compact route, embedding the driver directly onto the main board. Both approaches have their advantages, but what they share is the absolute need for reliability. These components have to survive thousands of on-off cycles, endure voltage fluctuations, and keep the light steady without flickering or overheating. At this point in the production line, the bulb's internals are beginning to sync. It's a small symphony of micro-components now fully assembled, from chip to board, from wires to drivers. Electricity will enter at one end, travel through carefully soldered paths, get conditioned and converted by the driver, and finally reach the LED chip in just the right form. It's the technical heartbeat of the bulb. Yet, even with all this carefully crafted tech sealed inside, the bulb isn't quite finished. It still needs protection, polish, and proof that everything works the way it should. But for now, it stands as a fully wired promise, ready to turn energy into light with a single flip of a switch. The globe covering the light. With the engine ready and the wiring in place, the next step is to protect and shape the light. That's where the PC cover comes in, the dome-like cover that gives the bulb its familiar look and helps spread the light evenly. It's more than just a finishing touch, it's the diffuser, the final frontier between raw brightness and comfortable illumination. Depending on the design, this dome might be made from either plastic or glass, and each material brings its own character to the bulb. Plastic covers dominate most production lines due to their lightweight and durability, and the way they're made is nothing short of mesmerizing. The process begins with injection molding, molten plastic heated to the perfect temperature, then shot into molds that give it that smooth, curved shape. Once cooled, the covers are crystal clear or gently frosted, depending on the desired lighting effect. In some specialized production lines, the classic charm of glass is still used. It's a slower, more delicate process involving glass blowing, shaping the red-hot material into seamless domes before letting them cool into a pristine, transparent shell. Whether glass or plastic, each dome must be flawless. Any bubbles, warps, or scratches can affect how the light disperses. When ready, these domes are moved to the assembly line, where robotic arms take over. With sharp, precise movements, the arms grip each cover, rotate it gently, and lower it onto the bulb body. The alignment is spot on, no guesswork here, and the snap into place happens in one smooth, satisfying motion. But snapping alone isn't enough when the bulb will face years of heat and pressure. That's where adhesive comes in. A tiny bead of high-performance glue is applied at the base of the cover. It's clear, strong, and built to last. It ensures the dome doesn't shift, crack, or loosen over time. Once sealed, the bulb gets one step closer to completion. This entire process happens in seconds, repeated over and over across thousands of units per hour. And the result? A perfectly shaped light diffuser that not only protects the internals, but also softens and spreads the glow into something comfortable, familiar, and pleasant. The dome isn't just functional, it's what makes the bulb instantly recognizable on store shelves, and in every room it eventually lights up. Watching this part of the process unfold feels a bit like watching high-tech ballet, a dance between heat, precision, and polish. Semi-automatic magic, humans plus machines. Here's where things get really cool, the semi-automatic production line. It's part machine, part human, and all efficiency. Workers place the assembled PCB into the bulb base and feed it into the machine. It presses everything into place with just the right amount of force. The machine also leaves enough room for the PC cover to be added later. Spacing is everything here. Next comes the socket. Whether it's an E27 or B22 base, the socket is added and locked in. Some are screwed, some are clipped, but every one of them has to be snug. A loose socket is a safety hazard, and this process doesn't allow for mistakes. Even at this speed, rotating with thousands of bulbs moving per hour, every single one is handled with care. The aging rack, a wall of light, science, machinery, and a little mystery blend together to create Spam. But forget what you think you know about canned meat. This is not a story about mystery meat in a tin. It's a cinematic journey through automation, innovation, and a magnified sense of tradition. Picture a race against time and bacteria, a perfect blend of old-school butchery and new-school robotics, where nothing is left to chance and every can carries a story. So buckle up. You're about to get an all-access pass inside the mega factory where millions of cans of SPAM are produced every single day. Pictured on, or breaking over a sprawling complex, trucks loaded with pork shoulder and select ham, their contents chilled and temperature monitored, rolling in just as the night shift finishes, scrubbing every inch of the facility to hospital-grade cleanliness. No meat enters this temple of engineering until rigorous quality checks are completed. Each shipment is scanned, sampled, and signed off. The journey begins with the selection of only the best cuts. Spam relies on premium pork shoulder for its soft yet firm texture, while the addition of ham brings a richness that's unmistakable in the final product. You may think all pork is created equal, but at this stage, even the smallest subpar detail means rejection. That's because making something as simple as Spam requires 1,000 layers of discipline, know-how, and absolute precision. Once accepted, those perfectly marbled hunks of pork shoulder and ham are transferred into the chilled prepping area. This is where butchery transforms from craft to science. Gone are the days of blood-spattered aprons. Now, skilled staff and machines work together in a serenade of speed and exactitude. Advanced cutters and pneumatic tools separate bone from flesh, slice away unnecessary fat, and portion the meat into just the right sizes. Workers and AI-powered vision systems double-check every step. Even the trimmings have a home. Anything not destined for this batch might find itself in another Hormel product, part of the company's zero-waste philosophy. Next comes grinding, and if you're imagining a kitchen mincer, think bigger. Each batch weighs in at about 8,000 pounds. That's roughly the weight of 2 city cars, churned through massive industrial grinders engineered for consistency. These powerful machines break the meat down, mixing the fatty cuts with lean ones, creating a homogeneous pink paste. Consistency at this stage is key. Too coarse? The final product won't have that signature bounce. Too fine? You lose the meaty texture that made SPAM beloved in the first place. And with every batch, metal detectors scan for any foreign objects. Safety isn't just a policy, it's wired into every action. But safety and quality don't end with grinding. Here's where Spam's secret weapon comes in: chilling and vacuum mixing. The freshly ground meat is mixed with crushed ice, instantly lowering the temperature. This ultra-cold environment does more than keep the batch fresh. It ensures the proteins won't break down or get rubbery during later processing. Inside the giant mixers, there's a literal vacuum, pulling all air out and further helping to prevent spoilage. This vacuum process is also crucial for another reason. It allows every particle of the mixture to bind together perfectly. So every slice of SPAM you eat is uniform from first bite to last. The benefits of vacuum mixing go beyond simple freshness and texture control. Removing air from the mixing chamber enables deeper seasoning penetration and keeps ingredient dispersal absolutely even, ensuring every portion tastes just as good as the next. This vacuum environment also aids in keeping colors bright and natural while locking in moisture, which leads to improved juiciness and shelf life. By reducing oxidation, the vacuum not only helps prevent discoloration and spoilage, but also intensifies the flavors and preserves the nutritional integrity throughout the product's long journey from factory to your table. All of this is achieved in a process faster than traditional techniques, minimizing processing time and maximizing quality. A perfect example of how technology and food science work together to create a global staple. Suddenly, the smell changes. It's time for seasoning and more science. Salt is added, not just for taste, but for preservation, ensuring no bacteria can survive. Sugar comes in to balance the saltiness, potato starch for that smooth, spreadable texture, a carefully measured splash of water to bind it all, and then sodium nitrite. This small but vital ingredient locks in the product's iconic pink hue and ensures that even after months on a shelf, the taste and safety endure. The exact blend of seasonings is closely guarded, part of the brand's DNA. Imagine the pressure in that control room. A single pinch off, and millions of cans could taste dull, salty, or, heaven forbid, not like SPAM at all. Meanwhile, technicians in spotless lab coats hover over sample lines, pulling shavings and spoonfuls from each batch. They run physical and chemical tests, checking color, pH, texture, and weight. If anything's off, computers alert the operation team, and the whole line pauses for troubleshooting. Efficiency counts, but perfection is the real factory law. All this, and you're only halfway to having a can in your hand. The now perfect meat mixture is whisked via ultra-clean stainless steel pipes toward the filling area, where automation takes over, ramping the process up to 90 cans filled per minute at peak operation. Each can is precisely aligned and filled, with cone-shaped nozzles injecting the measured portion in a single smooth motion. Sensors track fill weight and scan for air bubbles. Once filled, each can is vacuum sealed in a matter of milliseconds, sucking out every last trace of air before the lid clamps down. This vacuum seal is not just insurance against spoilage, it is the reason Spam's shelf life can stretch for years. Pause for a second and watch the ballet of machines as every can is stamped with key data: production line ID, exact time of filling, and batch number. This level of traceability is key for food safety. If an issue is ever discovered, say with a single farm's meat shipment, every can be traced instantly and withdrawn if needed. This is modern food security at its best, but the drama isn't over yet. The next phase might be the most crucial: thermal processing, or what workers call retort cooking. Sealed cans travel into cavernous industrial-sized chambers called hydrostatic cookers, some large enough to fit a city bus. Here, they're exposed to a carefully calculated mix of steam and pressure, reaching more than 240 degrees Fahrenheit. The objective? Sterilization and perfection. The heat denatures meat proteins, shrinks and binds them, and kills any bacteria that could possibly remain. But it's a delicate balance: too hot or too long, and the meat dries out; too little, and the product is unsafe. Banks of sensors and computers track every variable, adjusting on the fly even for the smallest fluctuations. At the end of their steamy journey, the cans are rapidly cooled, zipped through showers and baths that bring them back to room temperature in minutes, a necessity to halt cooking and keep the texture just right. Now they fly down the conveyor to be inspected again and again, both by humans and machines. Each can is rotated, scanned for defects like dents or leaks, and checked for proper sealing. The label application process is next, and in true factory fashion, it's another hypnotic show. High-speed rollers gently wrap Spam's classic blue and yellow branding around each can with utter precision. Shrink-wrapped and coated, they're robotically stacked into boxes and immediately sorted for global shipment. Think the story ends as cans are packed for shipping? Think again, because the logistics of SPAM are nothing short of Herculean. Pallets are automatically loaded onto trucks or into containers, bound for supermarkets, corner shops, military bases, and even remote Pacific islands. That's right, Spam's enduring popularity is owed in large part to how reliably and efficiently these logistical juggernauts work. From rural convenience stores in America's Midwest to high-end restaurants in Seoul, Spam travels farther than most people do in a lifetime. And the scale is astonishing. Spam's distribution network spans over 40 countries, with cans crisscrossing oceans and continents thanks to multimodal transport systems that blend road, rail, sea, and air. Specialized warehouses handle thousands of pallets, tracking inventory movements with advanced logistics software that maps out optimal routes for rapid, cost-effective delivery. Supermarkets, local grocers, and even online retailers eagerly stock Spam for its long shelf life and universal appeal, making it a reliable choice for families, restaurant chefs, and emergency food supplies alike. Whether you're camping off-grid, preparing for a disaster, or plating up brunch in a city cafe, Spam's journey reflects a rare mastery of the global supply chain, a chain that never sleeps, constantly adapting to meet demand and keep this iconic food accessible across every corner of the world. And let's not forget, the magic of Spam isn't just what happens inside the mega factory. Once those cans arrive in homes, the ritual begins. A pop, a hiss, the twist and slide of that perfectly pink block onto the cutting board. Whole cookbooks are dedicated to this stuff. In Hawaii, slices are browned and layered atop rice, then wrapped in seaweed to make musubi, a local snack legend. In the Philippines, you'll find it alongside garlic rice and eggs, a breakfast feast with deep roots. South Korean kitchens prize it so highly, there's a gourmet variety that costs more than some cuts of steak. British chefs stuff it in fritters, and American chefs post SPAM burger hacks that rack up millions of views. In every corner of the globe, Spam transforms from humble can to culinary hero, its story shaped as much by culture as by manufacturing. None of this would be possible without obsessive attention to quality and innovation. Every year, the factory upgrades its machinery, swapping older filling robots for new AI-enhanced models. Software gets smarter, predicting maintenance needs before breakdowns occur. Sustainability is always on the table. Any leftover trimmings are repurposed. Every drop of water in the cooling system is recycled. Solar panels and high-efficiency chillers keep the carbon footprint shrinking. Let's sneak back to the QA labs. Here, food scientists analyze cans from every batch, sometimes keeping archives for decades. Why? Because an off flavor found years after production offers a learning opportunity. Harmful bacteria and foodborne outbreaks are nearly impossible if processes are followed. But the factory's team never rests. They're constantly seeking ways to reduce sodium, test new spice blends, or even introduce limited edition flavors to global markets that now clamor for variety. In some markets, you'll find Spam with cheese, spicy peppers, teriyaki, or black pepper. Each gets its own run. Each is carefully manufactured as the classic. Let's zoom way out and marvel at the numbers. Every day, tens of thousands of cans roll off the line. In total, more than 8 billion since Spam's debut. That's more cans than people on Earth. The production is so relentless, the system so finely tuned, that a single ingredient truck arriving late could send ripples through supermarkets in 24 countries days later. But what really sets Spam apart isn't just the product, it's what it means to people. Spam was born out of necessity during the Great Depression, then earned its place as a lifeline in World War II, feeding troops and civilians alike when meat was scarce and shelf life was gold. It inspired generations of cooks, from parents prepping quick breakfasts to celebrity chefs who turn it into artful dishes. It became a symbol of resilience, ingenuity, and even rebellion. Across Asia, Spam became a delicacy after U.S. soldiers introduced it during war. In the Pacific, it's beloved at celebrations and on weeknight tables alike. Its durability made it a staple in disaster relief kits. Its unwavering quality made it the darling of home cooks, campers, and busy professionals in need of a reliable meal. So, next time you pass by that unassuming can in the supermarket, think about the technology, heart, and history crammed into every steel rectangle. From the vigilant eyes scrutinizing meat quality at 5 in the morning, to the engineers and food scientists running round-the-clock shifts to guarantee safety and consistency, to the designers dreaming up tomorrow's flavors and eco-friendly packaging improvements. It's a world within a world, hidden inside an ordinary object you can hold in your hand. What's left to discover? Maybe a new recipe, a memory from childhood, or just pure, simple comfort when you open a can on a rainy day. But one thing's for sure, Spam made in a mega factory isn't just a miracle of food engineering, it's a symbol of how collaboration, science, and tradition can keep breakfast, and plenty of other meals, going strong for generations to come. Next time you crack open that can, you'll know the extraordinary journey your Spam has taken. From carefully selected pork shoulders on the farm through a meticulously clean machinist's wonderland, sprinting past robotic arms and steam chambers, and all the way to your fork. Ready for a taste? Because there's a whole history packed into every bite, a story of innovation, global culture, and that unbeatable pink perfection, locked forever in the world's most reliable little can. Ready to see the incredible journey of SPAM for yourself? Visit the SPAM Museum in Austin, Minnesota for fun, interactive exhibits, and inspiring stories from around the world. Admission is free for everyone. Discover the legacy? Imagine lining up every Duracell battery made in a single year. You'd wrap around the Earth more than twice. That's a mind-bending number of copper tops powering everything from remotes to smoke detectors. But how does Duracell actually pull off this insane pace of 10 billion batteries a year? Think about how invisible batteries are to us. They're everywhere. The remote you throw at the couch cushions, the flashlight you only remember when the power goes out, the smoke detector that suddenly starts chirping at 2 a.m. and makes you question every decision in life. We take them for granted until the moment they die, and then, suddenly, it's a crisis. Duracell has become the name people trust in those exact moments, partly because of that iconic copper top design, but mostly because for decades they've built a reputation for reliability. And yet, their story doesn't start with your TV remote or your kid's toy. It begins nearly a century ago and in a completely different world. Back in the 1920s, Samuel Rubin wasn't dreaming about AAs and AOAs sitting in blister packs. He was a scientist focused on developing better battery cells for specialized equipment. Alongside businessman Philip Rogers Mallory, they formed a company that at first made mercury batteries. And while mercury doesn't sound like the most user-friendly ingredient today, back then it was a breakthrough. These batteries became especially valuable during World War II, when the military needed cells that wouldn't give up in tropical humidity. The devices they powered had to keep running, no matter the climate, no matter the conditions. That reliability in the middle of war zones built the foundation for what would later become Duracell. The real shift happened in the 1960s. The company pivoted toward alkaline batteries, the kind you and I use every single day, and they needed a name that captured the promise: durable plus cell, Duracell. It was simple, but it was a promise. These little powerhouses would last longer than the competition. That brand identity solidified even further in 1973 when they rolled out the copper top design. Suddenly, you didn't even need to read the label to know it was a Duracell. It was sitting there in every grocery aisle, shiny and confident. That little bit of metal wasn't just branding, it was genius marketing that burned the image into consumers' heads. Ownership of the company bounced around over the years. First Kraft, then Gillette, then Procter & Gamble. Today, it's owned by Berkshire Hathaway. Yes, that means Warren Buffett, arguably the most famous investor alive, controls the batteries in your remote. You can almost picture him smiling every time you buy a 4-pack, knowing that even in the age of smartphones and high-tech gadgets, the humble AA battery still makes the world go round. So what actually makes up a Duracell battery? On paper, the recipe sounds like a science experiment that you'd probably fail in high school chemistry. Zinc, manganese dioxide, potassium hydroxide, graphite. Wrap that in steel, cap it with brass. Done. Except, of course, it's not nearly that simple. Zinc acts as the anode, or negative terminal. Manganese dioxide is the cathode, the positive terminal. Potassium hydroxide is the electrolyte, the part that lets ions move back and forth. The outer casing is nickel-plated steel, tough enough to handle the chemical reactions inside while keeping everything sealed away. And that copper top? It's not just decoration. It's a nickel-plated brass cap designed to help conduct electricity cleanly into your device. Now, lots of companies could throw these materials together and call it a battery. But Duracell's entire reputation rests on the fact that they don't just toss stuff in a mixer and hope for the best. They use proprietary additives, precise formulas, and rigorous quality control that ensures consistency across billions of units. Every batch of raw materials gets tested before it even enters the production line. If the zinc isn't pure enough, if the manganese dioxide isn't up to spec, it doesn't make the cut. That's how they guarantee that whether you're buying a Duracell in Georgia, or in Belgium, or in China, it'll perform exactly as expected. And speaking of Georgia, Duracell's flagship factory in LaGrange is basically a cathedral of battery making. Imagine a production line moving so fast it pumps out 300 batteries every minute at each assembly station. Multiply that by multiple lines and you're looking at over 3,500 finished units per minute. It's like popcorn in the microwave, except instead of a snack, you get enough power to keep half the gadgets in your house alive. The process starts with preparing the cathode mix, which is basically a carefully engineered cocktail of manganese dioxide, carbon, and secret ingredients Duracell doesn't talk about. This mix is pressed into little rings or sleeves that form the outer portion of the battery's core. Meanwhile, zinc powder is prepared with its own additives to make it more conductive and less prone to corrosion. These two powerhouses, the anode and cathode, are kept apart by a separator, a thin paper-like material that lets ions pass but stops the two from directly touching. Think of it like putting up walls between roommates who really shouldn't be living together but still need to share the Wi-Fi. The steel casing, which will become the body of the battery, is formed and nickel-plated to fight corrosion. The copper tops are stamped out of brass sheets, polished, and set aside for later assembly. Then comes the moment when everything comes together. The cathode rings slide into the casing. The separator goes in next. The zinc mixture fills the center. A carefully measured amount of potassium hydroxide electrolyte is added. And finally, the copper top is attached, along with a plastic insulating washer to make sure the positive and negative sides don't accidentally connect. Sealing the unit is a critical step. Too loose and the battery could leak. Too tight and internal pressure could cause problems. Duracell has spent decades perfecting this process. Once sealed, the battery moves straight into testing. Unlike some rechargeable batteries that need forming, alkaline cells like Duracells are ready to go as soon as they're built. But that doesn't mean they skip testing. Oh no. Every single one faces a gauntlet of checks that would make a Navy SEAL sweat. High-speed cameras look for visual defects. Automated systems measure voltage, resistance, and capacity. Samples from every batch are tortured with stress tests, extreme temperatures, accelerated aging, and leakage tests that simulate the worst conditions you could throw at them. One of Duracell's most important promises is that their batteries won't leak and destroy your expensive gadgets. That's why they put every unit through conditions harsher than anything you'd see in normal use. It's like training for the Olympics, just so the battery can live a quiet life inside your garage door opener. Packaging is another area where Duracell has flexed its muscles over the years. When they rolled out Duralock technology, promising a 10-year shelf life, it wasn't just a marketing slogan, it was a legit shift in how batteries were preserved. By sealing them more effectively, Duracell made it possible for people to toss a pack in a drawer and still expect it to work a decade later. That's not just chemistry doing the heavy lifting, it's smart packaging design working hand in hand with the product itself. And they didn't stop there. They added little power check features so you can actually test a battery before you put it in your device. It's like a sneak preview that saves you from the classic, "Is it the remote or the battery that's dead?" guessing game. For smaller coin-style batteries, Duracell went one step further and created child-resistant packaging. Anyone who's ever dealt with toddlers knows they'll try to put just about anything in their mouth, so making sure those shiny little discs are locked behind tough blister packs is a lifesaver. Literally. Sustainability plays a growing role too, and Duracell has been quietly reshaping how its products reach us. Over the years, they've cut down on excess packaging, ditched unnecessary plastic windows, shrunk the overall pack sizes, and boosted the amount of recycled material they use. Their philosophy is straightforward. When you're selling billions of packs every single year, even small changes add up to massive differences. Less plastic, less cardboard, less waste. It's a ripple effect that becomes a wave when you're operating at Duracell's scale. And it's not just what you see on the store shelf. Inside their factories, like the flagship plant in Georgia, they've taken sustainability just as seriously. That facility has committed to sending zero waste to landfills, which means everything is either reused, recycled, or repurposed. They've also slashed water usage by millions of gallons annually through efficiency upgrades. For a company that runs production lines day and night, cutting that much resource use is no small feat. These shifts might not be as flashy as the copper top design, but they matter, and they show that even in the world of disposable batteries, there's room for responsibility. Duracell isn't stopping at alkaline either. The copper top may be their superstar, but behind the scenes, they've been steadily building a lineup that covers just about every corner of modern life. They've got rechargeable batteries for people who hate running to the store every other week, ultra-tiny hearing aid batteries that pack a surprising punch, but sleek power banks that keep your phone alive when you're traveling, and of course, the Optimum line. That one's built for the gadgets that seem to inhale energy, high-drain devices like game controllers, motorized toys, and fancy flashlights, or for anyone who just wants their batteries to hang in there a little longer before giving up. What makes it impressive is how far the chemistry itself has come. The stuff inside today's Duracell cells is light years ahead of what you would have bought off the shelf even 10 years ago. They've squeezed out more power, stretched the shelf life, and made the whole package more reliable, all without changing the size. So your AA battery still looks like the same old AA battery, but it's been hitting the scientific gym behind the scenes. It's a little like upgrading your phone every few years, except your batteries keep evolving without forcing you to learn a new charging cable. They just keep slipping into the same remote slot, the same flashlight, the same controller, only now with extra endurance tucked inside. Now you might be thinking, this is all great, but it's still just a battery. Does it really matter? The answer is yes. In disaster zones, when the grid goes down, batteries keep radios alive, flashlights shining, and medical devices working. Duracell even has a rapid response program that delivers free batteries to areas hit by natural disasters. In developing regions where power grids are unreliable or non-existent, a simple battery might mean a child can study after dark, or a family can run a radio. That long shelf life suddenly isn't just a marketing feature, it's a lifeline. Economically, Duracell's global empire supports thousands of jobs directly and many more through supply chains. The factories not only power your gadgets, they power local communities. And that's part of why Duracell has managed to stay not just relevant, but dominant in an age when technology is constantly shifting. From its unlikely beginnings in the 1920s through military breakthroughs in the 40s to consumer dominance in the 70s, and now as a global powerhouse under Berkshire Hathaway, Duracell has built its name on one simple promise: reliable power. Billions of times a year, that promise gets fulfilled in devices all over the world. So the next time you pop a copper top into a smoke detector or shove a couple into a game controller, remember the journey it's been on. From carefully tested raw materials, through high-speed assembly lines, brutal quality control, and into packaging designed to keep it fresh for years. It's more than just a little cylinder of chemicals. It's 100 years of innovation squeezed into the palm of your hand. And if you enjoyed getting an inside look at how something so small makes such a big impact, complex, tiny moving parts, bright colors, strict safety standards, and often batteries or electronics inside. In Guangdong province, factories use high-speed injection molding machines that can churn out hundreds of plastic parts in minutes. But what's striking is the human-machine collaboration. Robots handle precision assembly, while human workers focus on creative quality control, like painting the eyes of dolls or ensuring that the color finish matches brand standards. The hybrid model ensures both efficiency and craftsmanship. If you think about it, the same principles apply to Lego, which relies on ultra-precise molding machines. Though Denmark still makes its premium bricks at home, many accessory pieces come from Chinese plants. Another overlooked detail is how safety is built into these factories. Every toy undergoes multiple durability tests, from bite tests for toddlers to chemical checks for paint toxicity. This level of care dispels the myth of sloppy, unsafe production, showing instead a system tuned to global compliance, often stricter than Western regulators demand. Electronics recycling is another breathtaking process. Imagine mountains of discarded laptops, smartphones, and appliances being fed into giant shredders that strip metals, plastics, and rare earth elements apart like peeling layers from an onion. In cities like Guiyu, once infamous for dangerous e-waste handling, new government-backed plants have transformed the industry into something far more futuristic. Conveyor systems sort components, AI-controlled machines extract reusable chips, and advanced smelting furnaces recover gold, cobalt, and lithium. These materials are then funneled directly back into the supply chain, sometimes even into the very same factories that produce new devices. The closed-loop cycle reflects a profound shift. China isn't just the end-of-life graveyard of global electronics anymore, it's also the rebirth center. Compared to the US or Europe, where e-waste recycling is fragmented and often outsourced, China has built a centralized industrial-scale infrastructure that ensures maximum recovery. For consumers, this means the phone you recycle today may literally become part of tomorrow's device. Furniture production is another striking showcase of scale and innovation. What used to be a craft of carpenters sanding wood in workshops has turned into smart factories filled with CNC routers, automated varnishing lines, and robotic arms that can assemble an entire chair in under 5 minutes. In Dongguan, for instance, there are factories that can output 20,000 chairs per day, yet each can still be customized with different fabrics, finishes, or designs based on orders. This mix of mass production and personalization is what makes China unique. It's not just about standardization anymore. Some factories are directly connected to e-commerce platforms like Alibaba or JD.com, meaning a customer's click in Germany can instantly trigger production of a sofa in China, shipped out in days. Compared to IKEA's centralized model in Europe, this responsiveness gives Chinese manufacturers an edge in both speed and flexibility. The food processing sector often surprises outsiders because they assume mechanization is limited to tech goods. But in reality, food factories in China are some of the most automated in the world. From noodle production lines that can process 10,000 packets an hour to automated dumpling makers that replicate centuries-old hand-folding techniques, the efficiency is unmatched. In Shandong, seafood processing plants deploy robotic arms to debone fish at speeds human hands can't match, while maintaining hygiene standards that meet or exceed European benchmarks. This modernization solves two problems at once: ensuring food safety in a nation still scarred by past scandals and producing enough volume to feed not only 1.4 billion citizens, but also export markets across Asia, Africa, and Europe. It's no exaggeration to say that the global instant noodle industry, for example, runs on Chinese machinery and expertise. Steel and heavy machinery manufacturing take the scale conversation to another level entirely. Walking into one of these factories feels like entering a sci-fi set. Giant furnaces, glowing red, robotic cranes moving tons of molten metal, automated rolling mills producing sheets of steel longer than football fields. The modernization here is crucial because steel has always been the backbone of industrial development, and China produces more than half of the world's supply. What's new is the green shift. Many plants are experimenting with hydrogen-based furnaces and carbon capture systems to cut emissions. Compared to traditional steelmaking in Europe or India, China's integration of smart monitoring, predictive maintenance, and AI-driven quality checks makes its output not only larger in volume, but also cleaner and more sustainable. The automotive sector is where Made in China 2.0 truly shines. While the world once dismissed Chinese cars as cheap imitations, today factories like those in Shanghai and Changzhou are producing world-class EVs that rival Tesla. Watching a modern auto plant is mesmerizing. Robotic arms welding car frames in perfect sync, automated guided vehicles carrying parts across assembly lines, and entire vehicles being tested with AI-driven diagnostic systems before they even leave the floor. The efficiency here is astounding. Some plants can roll out a fully assembled EV every 45 seconds. The ripple effect is even bigger. China is now the global hub for batteries, meaning that the heart of the EV revolution, the lithium-ion pack, is both produced and assembled there. Compared to legacy automakers in Detroit or Germany, China's EV factories move faster, adapt designs quicker, and integrate supply chains more tightly, which is why they've been able to flood international markets so quickly. Then there's the robotics industry itself, perhaps the most meta of all: robots making robots. In cities like Suzhou, factories produce robotic arms, sensors, and AI-driven systems that are then shipped globally to other manufacturing hubs. The irony is powerful. China, once criticized for cheap labor, now leads in replacing that very labor with machines. And these aren't basic robots. They're sophisticated units capable of delicate surgeries, warehouse automation, and even humanoid movements. By exporting these technologies worldwide, China isn't just fueling its own production, but shaping how the entire world will manufacture goods in the next decade. Finally, renewable energy manufacturing, especially solar panels and wind turbines, has become a defining symbol of modern Chinese factories. Vast solar farms start here, with production lines slicing silicon wafers thinner than paper, layering them into high-efficiency cells, and assembling panels at mind-bending speeds. The scale is so massive that China produces nearly 80% of the world's solar panels. In wind energy, factories churn out turbine blades as long as a Boeing 747's wingspan, transported by specialized vehicles across highways. Compared to Western rivals, Chinese manufacturers dominate not just in quantity, but in cost-effectiveness, making renewable energy more accessible worldwide. The irony is that the country once criticized as the biggest polluter is now also the one enabling global decarbonization through affordable technology. Each of these processes tells a bigger story, that made in China no longer just means mass production, but mass production at a sophistication, speed, and scale the world has rarely seen. It's not just about cost savings, it's about redefining what factories can do. Whether it's recycling old phones into new ones, building EVs at record pace, or weaving clothes that track themselves across global supply chains, Chinese factories have turned efficiency into an art form, and the implications are enormous. Industries worldwide are either adapting to keep up or falling behind. What do you think? Is this the future of manufacturing, or will similar revolutions unfold elsewhere? If you found this tour of next-gen factory processes inspiring, don't forget to smash that like button, share with someone curious about tech and manufacturing, and subscribe for more deep explorations of how our world is being built. Drop a comment. Which factory process blew your mind the most? Let's unpack it together. Thanks for watching, and I'll see you inside the machines next time.